189. Today we're going to be reviewing the characteristics of linear functions. So this is going to be a review of previous material we've already learned. So let's go ahead and get started. In order for us to create a line, we need 2 points. In order to calculate the slope, also called my rate of change, I can use these 2 points. I can also use a table, or I can use the slope formula, which looks like this. Now, just as a reminder, slope means a lot of different things. Rate of change, and we also have difference in y over difference in x, which is also up, down, left, right, which is also called rise over run, which is also my fancy formula. All of these means exactly the same thing. Okay, so let's go ahead and take a look at this first example. Here they're asking me to calculate my slope. Anytime I hear that, my first thing is to go ahead and write out my formula. I always write it with the 2 negatives already in place, and I leave blank spaces. So I'm going to take a look at my numbers. Whoever's bigger, I'm going to try and make the 2's. So there's my bigger x, bigger y, okay, so I have a space for everything now. Let's go ahead and get these guys plugged in so we can calculate this slope. Noticing that I have a -7, so it's going to be a double negative. 2 negatives make a positive, 2 negatives make a positive, 8 over 16, 1 over 2. Now, I can also utilize my calculator to do this. So, same exact function as running a linear regression. I'm going to go to Stat Edit. I'm going to type in my x values. Now I'm going to go ahead and type in my y values. And remember, I only need 2. Now I'm going to go ahead and hit Stat Calc Option 4 and hit Calculate. It's going to spit back an equation, and I'm looking for just the slope, so this A, 0.5. Same exact thing as 1 over 2. So I got that right. All right, so here they're asking me to graph it, so I'm going to go ahead and take my 2 points, -8, -7, as well as +8, +1. I'm going to go ahead and connect them to the best of my abilities here. Okay, so I got those guys connected. And now they're asking me about the y-intercept. So I need to look at my range/y-axis, domain/x-axis. I'm looking to see where it touches the y, and I see it here at -3. So I'm going to write that out as an ordered pair. Now this should be the b part in my equation. So I'm going to go back over here and look and verify. Yes, that is. So it looks like I graphed that correctly. So now I'm going to go ahead and say, all right, my equation is y equals 1/2 x minus 3. So now I'm going to look for the x-intercept. That's going to be here. That's going to be 6, 0. Same thing for my 0. Now, if I needed to calculate this because I couldn't really tell what it is, I could also just change my y to a 0. Now I can solve for x. Multiply by my reciprocal, and I end up with the same exact value, 6, 0. All right, so let's continue forward. So we already talked about transformations as well. The slope-intercept form, y equals mx plus b, where the m is my slope and the b is my y-intercept. So we have 3 different types of transformations. Reflection is when m is negative. The graph reflects or flips. I'm going to flip across my y-axis. So let's take a look at an example like that. As you can see here, I put one slope is negative, one slope is positive. So let's take a look at the graph. And as you can see, they are mirror images with the y-axis acting as a mirror. This, same distance here, same distance here, okay? So all it did was just flip around to the other side. Let's talk about dilation. So when m is greater than 1, the graph gets steeper. When m is between 0 and 1, such as a decimal or a fraction, the graph gets less steep. So let's take a look at an example of that. Let's go back over here. I'm going to draw in a couple of slopes. So first I'm going to start with a really big slope. And I'm going to keep going down so you can kind of see the progression of it. All right, so I got 7 different graphs. Let's take a look at them. So less steep, less steep, less steep, less steep, less steep, less steep, less steep. Okay, good. So as my number goes down, it gets less steep, and a 0 slope is straight across just like the x-axis. Now, it looks just slightly different whenever we have negatives. So let me go ahead and drop in negatives here. So I'm dropping in negatives in front of everybody so we can see what happens here. Okay, so let's graph them. So notice how this is steep up here, less steep, less steep, less steep, less steep, and it's heading all the way towards 0. So even as we have negative numbers, way negative is more steep, less negative is less steep, okay? Now, a different way to think about that is like this. So over here I have a positive 10 slope. This is really steep. Way out here is really steep. In the middle, not steep at all. So the closer it is to one of these, you would say it's more steep, less steep, okay? All right, let's look at these translations. So these are my up, down shifts. So if B is greater than 0, the graph shifts up. If B is less than 0, the graph shifts down. All right. So the way that we should think about this is that we should kind of keep this as a set of rules, okay? So y equals mx plus b. A negative means to mirror. My slope and here is not steep at all here in the middle, and this is very steep out here and out here. And finally, my b value tells me up and down, with positive being up, negative being down. All right, so let's go ahead and take a look at a couple of examples. Here I have y equals 3x minus 5. So the line is going to get steeper and is going to shift down by 5 units. Over here, the line gets less steep because it went down, and we're comparing it to 1. Okay, 1 is like our standard slope, our parent equation, and it's going to shift up 1. All right. So just as a reminder, steeper because it's bigger than 1, less steep because it's less than 1, down 5 because b is less than 0, up 1 because b is greater than 0. So, linear equations from word problems. Slope, rate of change. Words that we associate with that are going to be each, per, every, things like that. For my y-intercept, it's going to be start, begin, initial, a fee, one time, things like that. All right, so let's look at these and let's go ahead and write out their equations. A costume rental shop charges the customer a $20 deposit fee plus $17.50 per day. Write the equation to describe the relationship between the cost, y, of renting a costume and the number of days, x, the costume was rented. All right, so first thing I see that this is $20 fee. That's a one-time thing. That's going to be a y-intercept. $17.50 per day. $17.50 per day. All right, next one. A costume rental shop charges a customer a $20 fee. So it's the same question. Oh, okay. So here they wanted us to plug it in. 3 days. Okay. So if I was to plug in 3 days, right, I could go ahead and work out the math. The other way for me to do it would be for me to go ahead and just plug in my equation and take a look at what the table shows. So I'm going to plug that in. 1750 per day and a $20 deposit. So let's take a look at the table. Over here, I'm going to look for x equals 3. Total cost would be $72.50. All right, last one. Marlon and Mimo went trick-or-treating. They got 15 pounds of candy and are eating it at a rate of 0.25 pounds per hour. Write an equation to represent this situation. Okay, so this one's going to be a little bit different, but I just need you to pay attention, all right? So first thing, here's my x-axis, y-axis. They said they started at 15 pounds. So that's up here somewhere, right? And they're eating it at a quarter of a pound every day. So my graph looks like this. It should have a negative slope. Started off with 15, but I'm getting rid of a quarter of a pound every day. Here's my equation. All right, so I want you guys to go ahead and work on the example questions, and I will see you next time.